Hello, so my name's Aled, and I'm a mathematician, actually. But hey, it could be worse. But probably not much worse, really. So mathematics is uniquely intimidating. It's the world's best conversation killer, I think. So I shall demonstrate this now by means of a short role play of like every dinner party I've ever been to. So, what do you do? Oh well, I'm a mathematician. Wow. I'm just going to be over here. It's always really awkward. So as you may have noticed by the fact that I'm sort of youthful in appearance, so I'm still a student at Cambridge. And there's this image of the maths student as this sort of introverted, shy, horrendously foul-smelling thing. And that's completely and utterly true, actually. It's just really true. And we spend all our lives just thinking about these abstract things, and there's no time for washing, really. I think a lot of people are quite scared of numbers. They're not things you want to meet on a dark alley late at night. I mean, why was 6 afraid of 7? All together, because 7, 8, and 9. Oh, the old ones are the best. And the worst. But I'm going to talk a bit of a bombshell now. But mathematics is not about numbers. Ooh. Okay, let me explain. So back in ancient Greece, the ancient Greeks were excellent mathematicians. But they were experts at geometry, which is the mathematics of objects, so like triangles, squares, circles, or angles, that sort of thing. So for instance, on the island of Samos, they excavated a tunnel through the entire island to solve a water shortage problem on one side of the island, and they started it from both ends. And would you guess it, the ends met in the middle. They got the angles just right. It would be really embarrassing if they hadn't got it right. You have these Greek people walking down from one end in, they're close like, we've done such a wonderful tunnel, and then they're in the mountain, and the people on the other end are shouting and they can't hear. It would be terrible. But they were great mathematicians, they got it right. However, as we have seen strikingly in the past year, the Greeks are just cripplingly and diabolically terrible with numbers. Great mathematicians, but they just can't do numbers. No, just a little aside. A guy called Euclid was the most famous Greek geometer, and he was so famous that right up until like the 19th century, people didn't just talk about geometry; they talked about Euclidean geometry. He was that big a deal they could put his name on the front of it. Now, doesn't this remind you of an advert? Let's see, a rich, succulent, triangular pyramid on a crispy, crunchy, biscuity square base. This is not just geometry. This is Euclidean geometry. Okay, we're getting to the maths bit of the set now, okay? Braced. There's looks of abject terror sweep across the front row as we talk about math. No, we barred all the exits. No, I should have thought about this before you came. I'll be gentle. Okay, let's think about some railway tracks, just going to the distance. Everyone picture the railway tracks, they're kind of parallel and they're going off. And we kind of take it for granted that if I asked an engineer to build me a set of railway tracks, well, there's only one thing he could really do, maybe that thing we've got in our mind now, they're just going off straight side by side into the distance. And that's indeed exactly what Euclidean geometry tells us is the only thing that he could do. But it turns out that the Greeks hadn't got it completely sussed after all. Two German mathematicians called Gauss and Riemann discovered that in a weird, abstract, mathematical, imaginary world, you could have non-Euclidean geometries, in which there wasn't just one, but infinitely many possible sets of railway tracks you could make. It's really weird. I think that you've got them next to each other, but they're different things you could do, and they're all really curly and bendy. I like to think sort of at the Network Rail planning meeting, they're sort of there. Okay, so we've dealt with the infinite number of monkeys, with the infinite number of typewriters typing Shakespeare on the track. We've done that was last week. But this week, we have infinitely many different possible railway tracks here. The timetable would be a nightmare. Timetabling that. But I think we're about halfway through sort of the maths bit, so I think we'll take a break for another bad joke. So there were two cats. There was an English cat and a French cat, and the English cat was called 1, 2, 3, and the French cat was called 1, 2, 3. And they're having a race. They're having a race across the English Channel. They're swimming. And why did the 1, 2, 3 cat win? Because the 1, 2, 3 cat sank. Right. You've got to have your system right, so back to geometry. So Bernard Riemann, when he was a drunk, mad, raving lunatic, made up these non-Euclidean geometries, and they were nice, but they're more just a mathematical curiosity, something to, I don't know, while away the time on a wet Saturday afternoon before watching David Spielholzer on Winter Wipeout. I mean, everyone knew that the real world wasn't this weird curvy thing. The vastness of space was beautifully flat and Euclidean. Except it's not. Okay? So you might have heard of curved space-time with Einstein's theory of general relativity. Now, I don't propose to talk about this today, it's quite complicated. But at its heart is one incredible idea that these weird alternative curvy geometries that were cooked up by Riemann quite artificially 60 years before Einstein are not just drunken abstract nonsense. They are, quite literally, the shape of the universe. And you're back in the room. How does that feel? Okay, want to lie down a bit nauseous? Do you feel like you're on a trip, sort of LSD hallucinations of Einstein driving a train running over a cat on curved space-time? I guess my serious point is that without the incredible mathematics of Riemann, Einstein would have been just another mad German with silly facial hair. I do sometimes get asked, why do you love mathematics? Isn't it all just numbers? And before I say, well, it's the booze, fast cars and chicks, really. I say, well, mathematics isn't just about numbers. It's about structure. It's about understanding the structure of an abstract thing and uncovering its remarkable beauty. On the other hand, scientists will take that abstract beauty to explain the physical beauty of the world around us. So maths isn't science, but without mathematics, you couldn't do any science. So maybe next time you're at a dinner party with a mathematician, the conversation might now go a bit like this. Okay, so what do you do? Well, I'm a mathematician. Wow. Oh, do you prefer Euclidean or Riemannian geometry? Weirdo. Great, thank you.